Today we're going to talk about multi-step equations. Now we solved a basic equation in the last lesson, and then usually just took us one step. We either had to multiply, divide, add, or subtract. In these equations, we're going to have to do multiple steps to solve for the variable. And when we say solve for the variable, solve means isolate or get it by itself. All through algebra, you're always going to be trying to get a variable by itself to figure out what it is. So remember when we had algebraic expressions, and we might have said negative 3n plus 4n, and then we said, okay, well I know what that is. That equals 1n. So that was called combining like terms. And when you have multiple step equations, you may have to combine like terms as well, or you may utilize that skill to be more efficient in your work. So for instance, number 1 on the activity 2-3 multi-step equations looks like this. Now, you know that to get rid of that negative 2, when I say get rid of it, that's really what I mean, because remember, we're trying to get n by itself. So that negative 2, we can add, and that makes it a 0. And we did that in the last lesson. We just have to remember whatever we do to one side, we have to do to the other side. The key in these multi-step equations is to do one thing at a time. So notice I'm rewriting everything on the left that I still have there. Negative 6 plus 2 is negative 4. Now, right here, negative 2n plus 6n is 4n, and I know that because I can combine like terms. Now there's a 4 in front of the n, and there's an imaginary multiplication happening right there. So we will divide both sides by 4, and n will be negative 1. So the first thing you do in these multi-step equations is to get rid of your constants. Once you have your variable all combined, then you can do your multiplication or division. So in PEMDAS, we did multiplication and division before we did addition and subtraction. Well, in solving, we're kind of undoing all those operations, and we're going to go in reverse. So usually we will do our addition and subtraction first, because we're kind of working backwards. We're undoing the things that have been done. So let's go and look at number 26, because it's a little more in-depth. It has a distributive property in there. And it's fairly complicated. So always when we see this distributive, we want to draw our humps. So that turns into negative 5 plus 35m minus 42m plus 60 equals negative 8m minus 4m. So we have some like terms. We have like terms on the right, and we have like terms on the left. Cannot mix the left with the right. There is an equal sign there that you need to always remember as a boundary. You cannot just cross over it without using inverse operations or doing two things, one to each side. So these like terms on the left will turn into a negative 7m, and it's still going to equal whatever's on the right, negative 12m when we combine. Now I have another set of like terms, negative 5 and 60, so I can combine them to give me 55 minus 7m equals negative 12m. Now if you notice, I have an m on both sides of my equation, or my equal sign. That hasn't happened to us yet. Well, you're going to treat it just like you do any other number. And you're going to get all of those on one side of the equation by utilizing inverse operations. So we'll just add that 7m to both sides, and that will give me a negative 5m on the right. Now the reason I added this negative 7m instead of the negative 12 is because I know I want this number by itself as well. I need all the m's on one side and all the plain old numbers on the other. Had I done the opposite, it would have just taken me 2 extra steps to get to the end. Nothing would have gone wrong, nothing would have burst into flames. It's just more work. I know I need all the variables on one side and all the constants on the other. Therefore, I chose to move the 7m out of the way. Now when I get here, it looks just like we started with our one-step equations, and negative 11 equals m. So this should get you started, and this was a short explanation, so if you want to go to YouTube, what you want to search for, or some free math games, you're going to be at about a 8th or a 9th grade level if you're going to play some games to practice this skill. The only way to get good at it is to practice. You could YouTube some videos on solving one variable equations. And you could also make sure you're looking at multi-step algebraic equations. But you want to make sure whatever you're looking at only has one variable. These get very complicated and get into multiple variables and multiple exponents and all that kind of stuff, and that's not where you want to be right now. So if there's a grade level posted with the game, make sure you're at that level. You might go to a 10th, but definitely no higher than that because you're going to get into too many variables. Okay, good luck.